Can the new Ferrari SF-26, with its revolutionary technology and Hamilton's experience, break the red curse and take them back to the top in 2026? The calendar read January 16, 2026. In Maranello, a thin layer of frost covered the roofs of the Ferrari facilities. The silence was almost ceremonial. It wasn't just any day. It was the day when the heart of the SF-26 would be lit for the first time, the engine that could change everything for the Scuderia. On that icy morning, two iconic figures crossed the corridors of the technical center. Charles Leclerc, the team's emotional heir, and Lewis Hamilton, the seven-time world champion who, after leaving Mercedes, had come to Ferrari in search of redemption or definitive glory. They both knew what was at stake. That engine, known internally as Project 678, was not simply an evolution of the previous one. It was a complete break from everything Ferrari had done in recent years. Since April 2025, when the team management made the radical decision to abandon the development of the SF-25, every resource, every engineer, every minute of simulation had been poured into this new machine. And now, in front of them, it was about to come to life. Leclerc, motionless, crossed his arms. His eyes did not blink. His expression went through an emotional sequence in a matter of seconds. Clinical attention, genuine surprise, and finally a smile that overcame his self-control. It was the face of someone who knows, doesn't believe, knows that this time it could be different. Hamilton, for his part, broke protocol without saying a word. He took out his phone, took aim, and recorded. Not out of vanity. Not through social networks. He recorded because he understood that this moment had to be captured. It was a silent validation of all the sacrifice that had been involved in abandoning the Mercedes project. It's not every day a pilot hears an engine that could change his destiny. The gesture was minimal but forceful. As the engine reached its peak revs and then stopped in a low hum, the room fell into complete silence. Just seconds later, a round of applause broke out among the engineers. But Hamilton did not immediately applaud. He watched his video, nodded slightly, and put the phone away. It was a silent but unmistakable sign. I had heard something different, something real. That moment marked the beginning of a narrative that could redraw the history of Ferrari and modern Formula One. And at the center of it all is an engine. And a pilot who no longer has time for mistakes or patience for half-finished projects. For Hamilton, this is not a news cycle. It is his last assault. For decades, Formula One has been governed by certain technical dogmas that almost no team dares to challenge. One of them, aluminum cylinder heads. Light, highly conductive, easy to machine, and sufficiently resistant. Until now. But in 2026, Ferrari decided to go against all that conventional logic. His decision was so radical that at first it was not even understood by many within his own team. To replace aluminum with steel in the engine heads. To understand what this means, you have to look beyond the materials. Aluminum has been the standard in F1 for a simple reason. Its reduced weight allows the engine's center of gravity to be lowered, a critical factor in the car's balance. But steel, heavier and denser, seemed crazy. Why then did Ferrari decide to bet on him? The answer lies in the limitations imposed by the new 2026 technical regulations and a bold vision for thermal performance. The new rules increase the minimum weight of power units from 120 kilograms to 150 kilograms. This upsets the traditional balance. With a heavier block already, the difference between using steel or aluminum is no longer as critical in relative terms. But steel brings a key benefit. Its thermal resistance is much superior. It can withstand extreme temperatures without deforming, without losing its shape, without failing. This allows the engine to be operated closer to its thermodynamic limits, right where the highest energy conversion efficiency is achieved. What's most impressive is how Ferrari solved steel's biggest problem, its weight. Using additive manufacturing, that is, 3D printing with industrial metals, the team managed to build components that are hollow on the inside, with millimetrically placed reinforcements only where they are necessary. The SF-26 stocks are not solid blocks. They are internal structures designed as if they were functional skeletons, light but unbreakable. This ability to model the interior of the part without geometric limitations allowed the incorporation of internal cooling channels impossible to achieve with traditional machining. The result is surgical thermal control. Heat does not disperse as in aluminum. It stays exactly where it should be, intensifying combustion, improving gas expansion, and therefore piston thrust. All this without compromising durability. And there is more. The change in material is closely connected to another key transformation. The new engine geometry that Ferrari is testing allows the relationship between electrical and thermal power to be dynamically modified during the lap. This, thanks to a deeper integration of the hybrid system, optimizes energy recovery and its reuse in short accelerations. In other words, the SF-26 doesn't just deliver more power, it delivers it smartly. But none of this was easy. In the early stages of development, steel cylinder heads showed serious problems with microfractures and fatigue deformations. Some on the team thought the project was doomed. It took the direct intervention of AVL and Renishaw, specialists in advanced simulation and digital metallurgy, to completely redesign the production process. Today, after thousands of hours of simulations, redesigns, and bench tests, Ferrari has something no one else has: a thermal combustion platform that can push the limits of performance without collapsing under its own heat. A technology that could give them back the advantage they have been pursuing for decades. But it also represents a high-risk move. Because if you fail on the track, there will be no excuses. There will be no turning back. Over the past few years, Ferrari had fallen into a dynamic that was wearing down both the team and its reputation. Technical promises that were not kept, designs that failed on the track, and a repetitive cycle of hope followed by frustration. But Project 678 has generated something that has not been felt in Maranello for a long time: genuine amazement within its own walls. When the first SF-26 data began to circulate among engineers, reactions were not immediately celebratory. They were a surprise. The simulation and test bench curves showed something unusual: a correlation greater than 90% between what the software predicted and what the engine actually delivered. For any F1 team, that figure is extraordinary. But for Ferrari, historically plagued by correlation problems between simulator and track, it was almost miraculous. One of the team's senior engineers put it bluntly: "I've never seen a heat flux prediction behave so faithfully on the real bench. This is a game changer." Precision is not just a matter of technical pride. It is the basis of all operational trust. If the car reacts as expected, strategic decisions become more accurate, aerodynamic developments can be implemented with less risk, and each improvement has a better chance of performing at its best. But the data alone does not explain the enthusiasm that is felt at Ferrari. What really impressed the technical team was the thermal stability of the new steel cylinder heads. Initial versions, developed in mid-2025, exhibited microscopic fractures after prolonged thermal cycling. The engine may have seemed powerful, but it was not viable for a full race. It was necessary to redesign the part from scratch using dynamic structural modeling, real-time stress simulations, and finite element analysis techniques. Even the track technicians have noticed the difference. The time needed to calibrate the engine when cold, the behavior under partial load, the response in slow corners. Everything is more predictable. Every bench session is no longer a "let's see if you fail" test. It is a validation of a hypothesis that almost always they already knew would work. This reduces uncertainty and allows more time to be spent on fine optimization, which can translate into valuable tenths in ranking. This precision has also strengthened the relationship between the design area and the track. Pilot feedback can be applied directly to thermal control and hybrid recovery algorithms. If Leclerc reports uneven torque delivery on slow corner exit, engineers can now isolate the pattern in real-time data, simulate a factory response, and upload it to the car in less than 24 hours. It is Formula One in its purest form: speed, intelligence, and execution with no margin for error. But all this represents great pressure. Because if Ferrari does not manage to translate into results what its engineers have achieved in the laboratory, there will be no technical shield that is worth it. They will be accused of having had the right weapons and having failed on the battlefield. This project is not just Ferrari's attempt to win again. It's Hamilton's last chance to redefine his story. If he fails, it will be the epilogue of an unrepeatable career. But if it works, if that engine responds on the track as promised in Maranello, then we won't be talking about another title. We will be talking about the perfect closing. Of the moment when a driver and a team, both marked by the pressure of their past, meet to write a last page that justifies each sacrifice. What Ferrari is doing with the SF-26 goes far beyond trying to win races. It's not just a new car. It is a declaration of intent. It is a direct message to the entire paddock, to its rivals, to its fans, and also to its own history. Ferrari has not come to participate. He has come to rewrite his role in modern Formula One. Are we facing the birth of a new era for Ferrari, or just another promise that will not come to fruition? Will this engine be the one that returns the championship to Maranello after more than a decade of drought? Or will it be remembered as a legendary driver's last great attempt to reach the top once again? Leave me your opinion below in the comments what you think about all this.